All right, last problem, problem 196A. And so in this problem, we have Woolsey Industries. Let's see, it tells us that it expects to maintain the same beginning and ending inventories. So that makes it a little bit easier. We don't have to do a few less calculations that way. So, all right, so it gives us their cost. So it's broken down by production cost, selling cost, administrative cost. Tells us what's fixed, variable per unit. And then it tells us how many units we're expected to sell, the price we're going to sell it at, and let's see, we don't really care about that just yet. So, all right, so it's has us start off by making an estimated income statement. So we have our little template over here. So we start off with sales, and so sales is just going to be the expected sales, which is $21,875 times our expected selling price, which we have all down right here. We have our cost of goods sold, so that's just going to be the units that we are expected to sell. Oops. Times our direct material cost per unit, which they give us at 46. Direct labor. So the units we're expected to sell times the direct labor cost per unit, which is 40. And then total factory overhead. So factory overhead, that has both variable cost and fixed cost. So the variable cost is the units times the cost per unit. Then we're going to add in the fixed cost of 200,000. All right, that gets us down to a gross profit of 981, and then we plug in our salaries and commissions. So that's going to be fixed and variable as well. And total advertising cost is just fixed at 40,000. Travel costs are fixed at 12,000. And our miscellaneous $29,000. Go to our administrative expenses. So office salaries are fixed at 132. So the variable portion of supplies is $4 a unit plus 10,000. And miscellaneous administrative fixed and variable. Okay, so that gets us total expenses of 681,000. Subtract that from our gross profit, gives us profit or income from operations at 350,000. So not too bad. And so part 2, it says what's the expected contribution margin ratio? So the contribution, so that's just going to be the contribution margin divided by sales. So our sales is going to be 3.5 million. And our variable cost, now it's not broken out here in our income statement what's variable, but we do know the variable cost per unit is 120, and we multiply that times the units that we're going to sell at 21,875. Will give us our total variable cost. So that means we have a contribution margin of 875. Divide that by our sales. Is 25%. So for every dollar that we're going to sell, 25 cents is going to be available for fixed cost. All right, so number 3. So now we want to determine the break even, both in dollars and units. And so take our fixed cost, which they give to us at 525. Divide that by our contribution margin ratio, which we already calculated. So our break even in dollars is 2.1 million. So we have to sell 2.1 million worth of goods to break even. So how many units is that? So for break even units, that's going to be our fixed cost divided by our contribution margin per unit. So it tells us what the sales price is 160. And we know what the variable cost is as 120. So the contribution margin per unit is going to be $40. Which means our break-even sales in units is going to be 13,125. Alright, so the part 4 says construct a cost volume profit chart indicating the break-even sales. And so this one, I already plugged it in, just a little quicker to look at. And so all this is just a really simple chart in Excel that shows, so our blue line right here is going to be the sales. And so our sales essentially for every 1 unit is going to go up by $160. So every time we sell more, it just goes straight up. Nice linear equation. Now our total cost, that's a little bit different because they don't start at 0, because we have fixed costs of this 525,000. So fixed costs automatically start even if we don't sell anything at 525,000, and then it slowly goes up by our variable cost, which was what, $120 a unit. And so what happens is we're selling these units right along this line. So anytime our blue line is below our orange line, we're gonna have a loss. And then once we figured out our break even in units, which is the 1325, so right about here when we get to that 1325, the lines intersect, which means we're at exactly 0 profit. Then anything beyond that, we start seeing that blue line get higher, and that means we're making more and more profit as we go along. So the break even in units is right here at 13,125, and also the break even in sales dollars, if we go over this line, it's at 1.2 million. So just right about here. And if you guys want to look at how that's calculated, here's just the numbers for the chart plugged in over here. Any numbers will work to get this graph. So you can plug in anything for sales units. I just did it in increments, so we actually got exactly to the 13,125, but it doesn't matter. Your sales column, it doesn't matter as long as it's just units times your sales price of 160. And the total cost formula is just variable and fixed. So that's always going to be the 525 of fixed plus our variable cost, which is 120 times our units. So, okay. So last two, let's move this over here. So it asks us for the margin of safety. And so the margin of safety, all that means is you take, hey, what you're expecting to sell and then subtract out your break-even point. And that's going to tell you, hey, how much wiggle room do I have where I'm still in a safe zone? And so if we take what we're expected to sell at the 3.5 million, and we take our break-even dollars, we calculate that at 2.1 million. That means we have a margin of safety of 1.4 million. So we know that, hey, if our sales expectations are wrong, we have $1.4 million to play with until we actually have a loss. And so then ask us to do, hey, do the break or the margin of safety in as a percent of sales. So that's just margin of safety, sales minus break even. So that's our 1.4. And divide that by our sales. So 40%. So we could basically miss our estimate by 40% and we'd still be okay. We wouldn't have a loss. So that's a pretty good margin of safety. If you're missing your expectations by 40%, then you need a new estimator. That's missing by a lot. And so the last one is operating leverage. And so operating leverage is essentially, that's just, the more leveraged you are means the more money you're going to make, the more units you sell. And so what that is so the higher margin you have, so the higher contribution margin, which means you have lower variable cost. So the more contribution margin you have, the more you're going to take advantage of sales as they grow higher. And so if you're a very leveraged company, or if you have a very leveraged product, that means you stand to make a lot more money if sales are high. On the flip side, it means more than likely you have probably higher fixed cost. And so while you can really take advantage of in the high end, if you sell a lot, you're going to make a lot of money. If you don't sell a lot, you could also lose a lot of money. So leverage is also kind of a measure of risk as well. Highly leveraged, you make a lot or you can lose a lot. If you're lower, you have a lower leverage. Chances are, you're not going to benefit as much from selling a ton, but you're not necessarily going to lose a lot either if you don't sell very much. So the formula for that is just our contribution margin. Which we've already calculated right over here, 875. And we divide that by our income from operations, which we calculated over here. So it gives us an operating leverage of 2.5. So that means our contribution margin is 2.5 times total profit. So whether that's high or low, it really kind of depends on what industry you're in. From some industries it could be really high, from some it could be really, really low. If you're in the grocery business, that's probably a super high leverage, because most grocery stores, when they sell stuff, have a very low margin. On the other hand, if you're, let's see, what's a high leveraged business? Anyway, can't think off the top of my head, but so it could be low. It's kind of depending on what industry standards are. So. Anyway, so that is problem 19-6.